To begin, all good maths courses, algebra. It's our language, our alphabet if you like. And we start with this golden rule. Like terms can be added or subtracted, unlike terms cannot. And that's the basis of everything we do in algebra. I don't think I bothered with an example on that one. I think we're probably on top of adding x and x and things like that. But it just highlights, remember, those terms have to be the same. Okay, some index laws, rules that we must obey, or the index police come and, anyway. When we multiply, we add the powers. When we divide, we subtract the powers. Parentheses situation, that's when we multiply the powers. And a little lie we like to tell you, anything to the power of 0 is 1. Yeah, it's a little lie because it's not true. Why is it not true? See, this is the beautiful thing about maths. Proving things really hard. Disproving things very easy. All you have to do to disprove something is to come up with one counter example. An example where it does not work. A to the power of 0 is equal to 1. I need to just come up with a number where that does not work. What is the number? 0. 0 to the power of 0 is not 1. Try it on your calculator if you do not believe me. See what it says. Because here's the problem. We've got another rule that says 0 to the power of anything is 0. Whoa, contradiction. Whoa. And you'll find your calculator will give you an error because it can't handle that contradiction either. Like, well, which is it? 0 is a very weird number. Some people don't believe it is a number. Okay? In fact, when it was first introduced, the idea of 0, there were people just, no. Okay? This is ridiculous. How can you have this thing? And basically they're saying, no, all it is a symbol that for representing the lack of value. Yeah, okay, well that's what 0 is, isn't it? Okay, but what do these indices mean? What do they mean? Now, initially we just said something simple like, oh, it's how many times you multiply the number by itself. That's a meaning everyone understood. And that's fine if it's positive, but I think of it this way. If you've got a positive index, that means top of the fraction. I go to the top of the fraction. If it's negative, I go to the bottom of the fraction. So if it's positive, I go to the top, negative, I go to the bottom. Because you think about a negative index, using that idea of how many times do you multiply it by itself? Well, it doesn't work anymore, that idea. Yeah? What is 2 to the power of negative 2? Oh, well, I'll multiply 2 by itself negative 2 times. No, you can't do that. I mean, that's ridiculous. So we've got to have a different way of thinking. In fact, it's probably more correct to say negative means put me on the other side of the fraction. Because if you had a negative index which is already on the bottom, then it sort of say, no, put me on the top. So you sort of swap sides. Same side, other side. So that's another way of thinking about it. If it's positive, I stay on the same side of the fraction. If it's negative, I can go to the other side. And it's like a little instruction. Once you move it to the other side, the negative disappears. It's done its job. It's gone. But then we thought we'd make life even more confusing for you and said, well, why do they have to be whole numbers? Can't we have a fraction as an index? So A over B. What does this mean? The top of the fraction in this case tells you what the power is. So that's why with whole numbers, not a problem. X squared, that's the power. 2's the power, because 2 really is, when you think about it, 2 over 1. So what's that bottom telling me? Well, that's telling you the root. So the opposite to the power. Instead of raising something to a power, raising it to a root. So that bottom of the fraction was 1. Technically, you're finding the first root of the number, which is a meaningless thing, and we never talk about it. The roots don't really start until we start talking about square roots. So where the number's 2. So it would be the bth root of x to the power of a. Of course, the lovely thing about it is the order you do it in doesn't matter. You might prefer to say, oh, I'll find the bth root of x and then raise it to the power of a. Other people might say, no, I'm going to find x to the power of a, then find the bth root of it. For a calculation point of view, The more sensible way, I think, to do it would be to find the root first, because finding the root will make it a smaller number, and then that's going to be easier to raise to the bigger number, rather than raising it to the bigger number. There, you've got a big number, and now I've got to find the root of that. But again, doesn't matter. This is personal preference. So let's have a look at some examples, starting with some very easy ones. So x to the negative 3, at this stage there is no fraction. My instruction is saying, hey, you're on the other side. Oh, okay. So that's 1 on x cubed. A to the 5b to the minus 7. So I've got two things here. So the positive number, no. You stay where you are. B, you go to the other side. A to the 5 over b to the 7. And then we go crazy. We love to do this in maths. You probably notice it. We try and make things look hard. It's still the same idea. They've already done some of the work for us. Look at it, 3/4. We already know 3's on the top, 4's on the bottom. Thanks for that. But then, negative, go to the other side, thanks. Positive, stay where you are. B, negative, go to the other side, thanks. There's the answer. Fractional, x to the power of a quarter. Top tells me the power, bottom tells me the root. I've got the 4th root of x. 2/3. Oh well, that's the cube root of y squared. Top tells me the power, bottom tells me the root. Other way round, 3 on 2. Top tells me the power, bottom tells me the root. However, with surd you will recall that we always simplify surds. That surd can be simplified because x cubed can be rewritten as x squared times x. And the square root of x squared is x. So we get x root x. Always simplify your surds. But there's a way of recognising that straight away. 3 on 2 is an improper fraction. Now we would never write it as an improper fraction with an index or it loses its meaning, because top tells you the power, bottom tells you the root. So whilst we see that, what we're thinking is that it's 1.5. Now our index laws say when we're multiplying we add the indices. So 1.5 is 1 plus 1/2. So we've got x to the power of 1 times x to the power of 1/2. Therefore it's x root x. So if you can break it into improper fraction, it's telling you how you simplify the surd. So I get something like this, ridiculous, but you never know. Why not? It's a number. 27 on 4. So it must be 6 3/4. So we've got m to the power of 6 and m to the power of 3/4, which is the 4th root of m cubed. Bingo. There's the answer. Okay, let's go crazy. We try to make things look hard. All right, here we go. I have drawn in, what have I drawn in by the way? Oh, sure, mere mortals would call it a fraction bar. What have I drawn in? Begins with a V. That is a vinculum. A vinculum. So the fraction bar is what's called a vinculum. Right. So I've drawn in the vinculum. Let's work out where everything goes. Well, half they've already done for me. We don't normally write 1 down in algebra with the coefficient, so I'll just pop the 2 on the bottom. N. Negative, you go to the other side. P. Positive, you stay on top. Q. Negative, you go to the bottom. Oh, but hang on a sec. It's 1 on 28, so that's the 28th root of Q. C. 7 on 6. You're staying where you are, but you're 1 and 1/6, so that's C times the 6th root of C. Okay. And then to the power of 69. Bit of yin and yang. It's a nice number, that one. Yin and yang. There it is on the top. To the power of 69. See, look at it. It looks like a hard question, but no. It's just the same ideas. Nothing changes. It's maths. Oh, by the way, that symbol here, which mere mortals call a square root symbol, the real name for that, what is it? Begins with R, this one. It's a radical symbol. It's a radical symbol. Okay. 2/3 to the power of -2. Okay. Fraction to a negative power. You know the quick way of doing this? Because remember that negative power says swap sides. Do it first. Swap sides, 3 on 2 squared, 9 on 4. Solve this equation. Wow. Exponential equations already? Wow. This one's a bit easier because I can rewrite these to the same base. Because 9, of course, is 3 squared. And so it becomes 3 to the power of 8x plus 2. And 27 is 3 cubed, but it's on the bottom of the fraction, so that's 3 to the -3. So now it's a very simple equation. 8x plus 2 is -3. We end up with -5/8. There's our first bit of theory. Woohoo!